Hey everybody, I'm Mr. Hartzler here with Hartzler University, and I want to talk to you about finding inverses. And these aren't the little ones, these are the big ones. These are with logarithmic and exponential functions, and we're usually going back and forth between these two things. So let's go and do quite a few examples on these. Alright, first one here, log base 2 of 3x cubed. First thing I need to do is switch my x's and my y's out. So now I have an x equals log base 2 of 3 times y cubed. Now I need to get my y out of my log. Right now it's inside a log. I don't have parentheses here, but that's what's happening. This whole thing, the 3y cubed, is all underneath or inside my log. I have to get it all out. So I need to get rid of my log. To do that, I'm going to go into exponential form. So 2 to the x power equals the stuff in this parenthesis. So 2 to the x equals 3y cubed. That's going from log to exponential form. If you have issues with that, go back and check out that video. Next thing I need to do is keep trimming everything off of my y and get it by itself. So I need to divide by 3. So now I have 2 to the x over 3 equals y cubed. Well, now how do I get the y by itself? Well, here I need to take this to the 1/3 power, or take the cubed root. It means the same thing, but I like the rational exponents. So I'm taking all of this to the 1/3 power. So now y is by itself, and I have 2 to the x over 3, all raised to the 1/3 power. But remember, that's not my y, that's my inverse function. So I'm going to write down f to the -1 of x, because that's how I represent my inverse functions. Let's go over to the one right next to it. I'm going to get the log. Oh, actually, I need to switch my x's and my y's first. Then I'm going to get the log by itself.
So switching those, I have x equals -7 log 6 of -3x. Okay, there we go.
Little point to bring up here. My original function, the stuff inside my log, that -3x, if I'm looking at my domain, I can't take the log of a negative number, which means the whole -3x, that whole thing in there, must be greater than 0. Let's divide by -3, and x and 0, but now I divided by a negative, so my inequality switches. X has to be less than 0. That's my domain of my original function here. Okay, I just want to point that out because we don't talk about that very often, but that's very important. All right. Ooh, I didn't switch them. This should be a y. There we go. Now I need to get the log by itself. Then I'll get rid of the log. So divide by a -7. So now I have x over -7 equals log base 6 of a -3y. Just like last time, I need to get rid of my log. To do that, I go from logarithmic form into exponential form. And to do that, I do my little loop-de-doop thingy, right? 6 raised to this equals the stuff in my parentheses, right? What exponent on a 6? Oh, so 6 is my base. What exponent on a 6 equals -3y? Oh, okay, so it equals -3y. Well, what was that exponent? It has to be this thing on the other side. X over a -7. Then I have to divide by -3. Then I have my final answer. 6 raised to the x over a -7. All of that divided by a -3 equals my inverse. Whew, looks ugly, but that's right. Let's go on and check out our next example. All right, I'm getting a little bit hairier here. Let's start off by getting the log by itself. I'm going to divide by 6. Okay, not bad, right? I have y over, ooh, I need to switch my x's and my y's. All right, forgot to switch my x's and my y's, so let's switch those out as I go into this next step. So x over 6 equals log base 2 of 2 to the y minus 7. All right, now I need to get inside here, so let's loop it again, right? Let's go into exponential form. 2 raised to the x over 6 equals the innards of this log, 2 to the y minus 7. Okay, we're getting somewhere. It's outside the log now, at least. But now I need to get that y even more by itself, so I'm going to add this 7 over. It's an easy thing to do, right? Now my bummer is that y is still an exponent. Well, how do I get things out of my exponent? Bringing in a log. So I know I'm going to need a log. What exponent on a 2 gets me the 2 raised to the x over 6 plus 7. That exponent is a y. Right? I'm unlooping this. So let's check ourselves. I think it's easier to go from log to exponential, so let's check. 2 raised to the y equals 2 to the x over 6 plus 7. That's what we have. Okay. But remember, that's not y. That's my inverse function. Sweet. There's another way of doing it, but we're going to ignore it for the moment, and maybe we'll come back to it. All right. Next one, off to the right side. I'm going to add my 7 first. That's the simplest part of this. So that's what I'm going to do. So x plus 7. X plus 7, because I forgot to switch my x's and my y's. That's the first step of inverses. All right, x plus 7 equals 6 log base 5 of negative 4x. Same thing as last time. My x has to be a negative number. My y has to be a negative number so that my whole log thing is a positive number. All right, we'll divide by 6, divide by 6. So now I have an x plus 7 over 6 equals log base 5. That's an ugly 5, but you get it. Of negative 4y. All right. Same thing as some of the other ones. It's inside my log. How do I get it outside of a log? I loop it. 5 raised to the massive exponent of x plus 7 all over 6. Ooh, ugly exponent. Equals negative 4y. I divide by negative 4. Divide by negative 4. Divide by negative 4. That's my answer. I'm actually running out of room, so I'm just going to cross this off and put a y. Oh, but not a y. It's actually my inverse function. Awesome. Right there. Oof, it is ugly, but it's what it is. All right. I know it seems weird on this one. We started with a log, and we ended with an exponential function. That's what you'd expect, because those things are inverses. But the one on the left, we started with an exponential function inside a log, which means I had to end with a log. That's how the cookie crumbles this time, all right? But whenever I have my variable that I'm trying to solve for as an exponent, I need to bring in logs. If I have something inside a log, this is like the one on the right, if something's inside my log, to pull it out, I need to get an exponential form. So that's how we're going back and forth. Let's go on and check out our next example. All right, so now I'm starting off with stuff that's just exponential form. Let's see if we can find our inverse. First, switch my x and my y. Next, isolate my x. Easiest part about this one is add over that 8. Okay. Now, I need to get my variable out of an exponent. Well, we're going to do this 2 ways this time because it's a little bit easier. So, I'm going to take this and put it into log form. Log base 5, and then x plus 8 equals my y, which, remember, is my inverse function. Okay. Not too shabby, right? That's it. We're done. Let's check ourselves real quick. 5 to the y equals x plus 8. 5 to the y equals x plus 8. Sweet. Again, I think it's easier to go from log to exponential form, so I always check myself that way. But now, I'm going to go right from this part. Okay, so I'm going to do this the same way, but just a little bit differently. That big difference, or the only little difference, I guess, is the kind of log I'm going to use. Last time, I went into log base 5, because that's what my base was. It was this 5, so why not go with base 5? This time, I'm going to use the common log. It's a common log for a reason, right? We use it a lot. We use it so frequently, it's the common one. It's the typical one. So let's bring in, on the left side of this, I'm going to bring in our common log. And on the right side of this, I'm going to bring in my common log. It's not a subscript or anything. I just ran out of room. So I brought a log in on both sides. Hopefully that makes sense with most of what we've done in math, right? The left side and the right side say the same. Awesome. Still good. Now, what does that mean? Well, now I can use my power property. I can take my exponent down front. So my left side is going to stay the same. My right side, my power property, that's a W there, power property, says the exponent can come down in front. So now it's a y times log of 5. Again, log base 10, because it's the common log. And what exponent on a 10 will get me a 5? I don't know what that number is. It's a decimal, but I know it's a number. So log 5 is just a number. Let's divide by it. Divide by log 5. Divide by log 5. Okay, on my right side, that cancels with that, and that's just my inverse function then. So this chunk right here is actually equal to this thing right here. The only difference is the base. That's actually how we can get a change of base formula. So let's use that and turn it into something here. Log B of A. Well, that equals log of whatever I want it to be. We'll say N of A over log whatever I want it to be of B, which is kind of neat. That's my change of base formula. Change of base formula. It's kind of neat. We use it not very often, mostly because calculators are just so efficient these days. I can use whatever kind of base I want and really get my answer quickly. But I just want to point this out because common logs are sometimes worth knowing. So let's do our next one. But I'm going to change colors. I'm not liking this Michigan situation here. Alrighty, we're over here on my right. Again, my goal is to isolate X. Well, it currently has a negative out in front of the whole thing. That's easy to want to get rid of. Oh, switch my X and Y's too. So now it's X equals negative 1 over 4 to the 1 plus Y. Let's get rid of that negative. So I'm going to multiply the left side and the right side by a negative. So my right side is now positive. Left is negative. And then I don't like this whole thing being in the denominator. Seems obnoxious. So what I'm going to do is I'm going to flip both sides of my equation. And I do that by cross multiplying kind of. So I'm going to multiply by 4 to the 1 plus Y on both sides. 4 to the 1 plus Y. So on the left, I have 4 to the 1 plus Y times a negative X equals a 1. Because on the right, that canceled with that, which is 1 over 1. Cool. But now I'm going to divide by that negative X. Okay. Now I have it the way I want it. I have Y is still in the numerator, in an exponent, but it's in the numerator. That's the good part. And if I have something as an exponent and I want to get it out of there, I need to use logs. Well, now, which one do you want to do? Do you want to do common logs or do you want to just go to the base? So in blue or in yellow? This isn't interactive, so I'm just going to pick one. Let's go blue. It's easier. All right, so log base 4 of negative 1 over X equals 1 plus Y. Let's double check ourselves, right? 4 raised to the 1 plus Y equals negative 1 over X. Sweet, we did it. Now we just have to subtract 1, and I can't break up any of that log stuff. I have to just leave it inside the log. I have to just leave it there, not mess with it. Minus 1 equals, and is my inverse function. What I mean by I can't mess with it is that negative 1 has to stay on the outside of those parentheses. Can't bring it in there. Doesn't change this base. Doesn't change my negative 1 over X. No. Just is out here. And again, X must be a negative number because otherwise the stuff inside my log ends up being a negative. So X has to be a negative in this case. All right, let's go on and check out our next one. All right, finding more inverses, starting off with exponential functions. I switch my X and my Y, so that's an X equals 6 to the Y over 4. Let's bring in a log. This time, let's use common log. Bringing in a common log on both sides. So now I have log of X equals log of 6 raised to the Y over 4, but I have power property. Sweet, that little sucker means I can move my exponent down in front. So let's do that. All right, so that's Y over 4 times log of 6. Well, I need to divide by log of 6. The logs don't cancel, people, right? What exponent on a 10 gets me an X? What exponent on a 6 gets me, on a 10 gets me a 6? I don't know, but I have to do that part first. That's like an exponent thing. I have to do the log part first before I could even try and cancel anything. So it is what it is. So that's a log X over log 6 equals a Y over 4. Then I need to get my Y by itself. That's my main goal. Never forget what your complete goal is. Finding the inverse means I'm solving for this Y now. So I have to multiply by 4. And over here, I multiply by 4. On the right, they cancel. So that as is now my inverse. That chunk right there. Sweet. That 4 could be out in front or in the numerator. Doesn't matter. Can't be on the denominator, though, because then it would be 1/4. Alrighty. Look at the one on the right. This one looks kind of ugly. But ugly can be fun. Switch my X and my Y's. Now, I'm going to recommend that we cube this. If I raise all of this on my right and my left, have to do it to both sides, to the third power, that 1/3 equals a 1, which means I don't have to do anything about it, right? So this is now an x cubed equals 4 to the y power over a -2. Sweet. Multiply by -2. And I have a -2 x cubed equals 4 to the y. Awesome. Last one I used common log. This time let's use a different log. What log should it be? Should probably be whatever base I have. So what's the thing with an exponent? Not the x. Ooh, actually, where's my y? That's a y, not a 6. That's a y. That ugly thing there. So I'm going to pick the thing with an exponent that I care about. So that's the one with the y on it. That's the log I'm going to use. Log base 4. So what exponent on a 4 gets me this thing? Well, that's this. What exponent on a 4 gets me this? Y, which is my inverse. Sweet. Go us. We're doing great. We're on fire today. And again, let's find our domain of this now. Domain of our inverse function. So a -2 x cubed must be greater than 0. Because the stuff inside my log has to be bigger than 0. That's just the rules. Divide by -2. Okay, so my inequality switches. So x cubed must be greater than, or sorry, less than, lights turned off, less than 0. Cube root both sides, cube root both sides. So x has to be less than 0. That is my domain. My range for log functions, right, because this is the function I'm dealing with right now, my range of that in all log functions is all reals. Sweet. Let's boot, scoot, and boogie to the next one. Ooh, still more, right? A lot of examples. I told you. First thing, switch my x and my y's. Then I'm going to square everything. So, first thing I need to do, get rid of this outside exponent. So, let's square the whole deal. So, x squared equals 3 to the y minus 4 over a -2. Well, next step, let's get rid of my -2. Multiply by a -2, because I'm just whittling away at everything until I'm getting the y stuff, at least the y term by itself. Then I'm going to get the y out of my exponent, because that's the bummerish part of the whole deal there. Alrighty, now I have 2x squared equals, well, those twos cancel, so 3 to the y minus 4. Add that 4 on over. Okay, now I have the term with y in it on its lonesome. Can't divide by 3 because my y is my exponent. Dividing by 3 doesn't do a whole lot. So instead, I'm going to go into log form. The most efficient way to go into log form is to use the base that my y is attached to. So that's going to be a base on my log of 3. Well, my equal side, that other piece, it goes inside my log. And then it equals y. Or in this case, for us, really, that's my inverse function. Let's double check. 3 raised to the y equals my innards. 3 raised to my y equals innards. Sweet. What exponent on a 3 gets me this? So what exponent on 3 equals this thing? Exponent on 3 equals that. Oh, well, it's a y. Cool. Sweet. We're making some good progress here. Well, I am at least. I can't tell if you're actually working or just watching or skipping. I don't know. All right, next one. I'm over here. Switching my x and my y's. Let's do that. All right, I got a log in there. How do I get my stuff out of my log? Go in exponential form. So that's 5 raised to the x equals stuff inside. Now I need to find the y. Okay, it's right there. It's on an exponent of, or it is an exponent of 3. So I need to whittle everything down until I get that term by itself. Multiply by 2. Multiply by 2. No, you can't multiply the 2 in the 5. I have to do my exponent on the 5 before I can multiply by the 2. That's PEMDAS. Right? I would have to do the exponent before I'd be allowed to multiply by 2. So I can't combine those things. So 2 times 5x is how I have to leave it. And that equals 3 to the y plus 9. Still getting the y by itself. What do I need to do? Subtract my 9. So 2 times 5 raised to the x minus 9 equals 3 to the y. Not too bad. But now I need to get my y out of my exponent. To do that, I go into log form. So where's my log of base 3 of 2 times 5 raised to the x minus 9. That all equals my y, or in this case, my inverse function. Let's double check ourselves. 3 to the y equals 2 times 5 raised to the x minus 9. 3 to the y equals that stuff. Sweet, we did it. Go team. Next one, folks. You ready for it? Oh, we're done. Sweet. Alrighty, folks. I hope all of you enjoyed this video. If you did, hit that like button down below. If you didn't, I don't know. Just don't like this video. But have a great day, everybody. Subscribe to the channel if you want to see more like this. And, of course, do math carefully and with enthusiasm. Bye, everybody.